Hey, hello, good morning, guys, and this is Coding with Gautam. And guys, today we will be doing the part six of the Emotion AI series. So let's dive in. Today we're going to be covering the new resblock function, then the training the network, actually seeing if it can be able to identify it, doing val loss, testing for accuracy, and I'm going to be giving a very in-depth explanation of how the resblock function works. So we're only going to be covering the function today. The accuracy testing will be in a separate section. So let us dive in. First it's just going to be how the code works, and then in the second half it's going to be the in-depth explanation. So this function defines the model architecture using the API. Input shape is set based on pre-processed image dimensions. The X input defines the input layer of the model receiving images with the specific shape, with the specified shape. And then the following lines define the convolutional layers, pooling layers, activation layers, which will be explained further. So then model 2 creates a model object. So we're gonna first look at the other code. Model 2 creates a model object which specifies the X inputs, X outputs as tensors for the assignment name. The name is the ResNet 18, and then the summary is basically show us the printed layers. So now let's go on to the model layers. So zero padding is the layer adds zero padding to the borders of the input, which can help prevent information loss during convolutions. Here it adds a padding size of 3 on all sides. So what it basically does is it basically adds some extra content to the edges of the image so that we don't lose the actual image. And then conv2D is the core convolution layer that extracts features from the input image. It uses the filter size of 7 by 7 with strides 2 by 2. With the number of filters 64, with the number 64 filters, this determines the number of features the map layer creates. The Glorot uniform initializer helps the parameter with initialization. So basically what this does is it creates the layer, and this is basically the crux of the actual function. It makes sure that we can actually identify specific parts of the function or the image, such as us being able to see whether it's smiling, its eyebrows are arched or not, and where the nose is positioned. Then, batch normalization. This layer normalizes the activations of the previous layer, improving training stability and speed. So, and the activation ReLU, it's basically applies the ReLU rectified linear unit activation function, introducing non-linearity to the network. So basically, this provides some more variation and makes sure that we can adapt and makes it non-linear. And then the batch normalization normalizes the activations of the previous layer, so it basically normalizes everything and makes sure that the model is stable. Then max pooling 2D, this layer performs downsampling by taking the maximum value of a taking the maximum value from a rectangular region with the pool strides 3 by 3 with strides 2 by 2 in this case. The res block, this refers to a function likely defining a residual block, a common building block in ResNet architectures. It involves convolutional layers, batch normalization, and potentially skips connections to preserve information. So basically what this does is it creates more layers. So it creates a 64 by 64 by 256 layer as the second, then it creates another layer with all these by 128, 128, and 512. So basically 128 by 120. So there's 128 rows where it will pass on information, and 128 columns, so the number of actual neurons. So okay, so then the final layers. So we do average pooling. This layer performs global average pooling, which summarizes the features from each channel into a single vector. Flatten, this flattens the pooled features into a one-dimensional vector. And dense, this is the final full connected layer with 5 neurons for each for one emotion class, such as happiness, sadness, disgust, surprise, and yeah, so it's happiness, sadness, disgust, surprise, and anger. Yeah, anger. All right. So then we go on to the model training. So basically, model training, this configures the network for the model to train. Optimizer is the atom, specifies the atom optimization algorithm for updating model weights during the loss. Loss categorical cross entropy basically defines the function used for measuring the error between predicted and actual emotions, and this is used for multi-class classification. The metrics of accuracy specifies the accuracy metrics to track during the training. So it tracks accuracy. Then we use the categorical cross entropy to calculate loss, and then we use the atom optimizer. So then the callbacks. These define callback functions used during training. Early stopping monitors value the validation loss. If the validation loss does not improve, the patience is 2020 epochs. So basically, if the model does not get more accurate after the 20th epoch where it doesn't get accurate, it stops so that it stops overfitting. Then model checkpoint basically saves the model with the lowest validation loss to this file facial expression weights keras, and then yeah, this ensures you have the best model. Then the training process, basically this line trains the model like we did last time. We put the data, X train, Y train, batch size 64, basically how much we're putting in each time. The validation data, what validation data we use, I talked about this in the last video. We validate using xval and yval. The steps per epoch, basically how many steps you do per epoch. You divide the actual train by the batch size to see how many times you have, how many batches you have. Then we use 16 epochs. You basically put the data to the model 16 times, and then the callbacks are check pointer and early stopping, basically making sure that we stop early if we're not improving loss, and check pointer is to ensure that we have the best file saved. And then after all that, we save the model, and then we have accuracy testing. So now let's go to the more in-depth. So this code here mentions a res block function. It's basically a ResNet architecture. ResNets are popular in CNN architectures that address the vanishing and exploding gradient problems in deep networks. They introduce skip connections that allow the model to learn the identity function along with the desired transformation. This helps the network train effectively with many layers. So then let's break this down again. As explained earlier, zero padding adds padding in the input. Padding 3 bit 3 on all sides retains same size after convolution. Con2D, this applies filters or weights to the input, learning features like edges, textures, or shapes. The filter size 7 by 7 and the number of filters 64 determines the complexity of the features learned. Like, will it just look for the color, or will it actually look for the grooves in the smile? Then the filter is 2 by 2, which reduces convolution operation. Slides 2 by 2 pixels in each direction after convolution operation, reducing the image size so it can be more focused. Batch normalization, this improves training speed and stability by normalizing the activations of the previous layer. It ensures the activations have a mean of 0 and standard deviation of 1. Then activation of ReLU. The ReLU activation introduces nonlinearity. It sets negative values to 0 and keeps positive values unchanged. This allows the networks to learn more complex relationships between features. Then max pooling. This layer performs downsampling, reducing the image size and computational cost. It takes the maximum value from a defined region, 3 by 3 with a stride of 2, summarizing the features in the region, then putting the layers together. So this model stacks multiple convolutional layers, and with batch normalization and ReLU activations, it extracts increasingly complex features. First, we look at the main features. Then as we keep going on, we look for the smaller and more finer details. The model gradually reduces the image size. So we start with the whole image, and then we keep going down to see what small details we can find. And then it captures, and more filters means the more intricate details we catch. Then the final layers. So average pooling 2D, this performs global average pooling. Instead of taking the maximum value, it averages the activations on each feature map, summarizing the information from the entire image into a single vector for each filter. So basically, it makes sure that all of it's put into 1 and then passed down. Flatten, this reshapes the pooled features from a multi-dimensional tensor into a 1D vector, preparing it for final classification layer. And then Yeah, the dense. This is a fully connected layer. This is like the final thing. It takes the flattened features and performs as a final classification. It has 5 neurons, one for each emotion class: happiness, sadness, anger, disgust, and surprise. And uses softmax activation to output a probability distribution for each emotion class. The class with the highest probability is basically the emotion that the image predicts. So, yeah. Then the model training and callbacks. Early stopping and model checkpoint, we talked about that before. Early stopping, it basically makes sure that we don't overfit the model, make sure the model is good, and we don't like train it on the same day the data too many times if we're not getting an increased accuracy. Then checkpointer, basically make sure that we have the best model saved. Then the overall model workflow. The model receives a pre-processed grayscale image. Zero parting adds borders to the image. Convolutional layers with ReLU extract the features of the image, progressively becoming more complex. Batch normalization improves stability. Max pooling layers reduce the image size while summarizing local features. The res blocks if introduce skip connections. Average pooling summarizes features from the entire image. The flattened image basically is condensed into one final layer. Softmax basically shows that what is the best emotion, and then during training the model learns to minimize the loss between predicted and actual emotions. So I hope this in-depth explanation of how the residual block function works and how we are actually creating the AI and what the neural network does. Like I said, this is the in-depth video I was talking about. So please check this out if you do not understand. And if you have any more questions, please shoot me down in the comments. I will be glad to help you. This is Coding with Gautam. Thank you guys for watching. Hope you continue with the series. And we're just really close from finishing our model. So thank you for sticking with this series. And yeah, have a good day.